Question is a real valued signal x of n whose power is 5 and its real part is 1 by 2 whole power mod n, and the power in output is, we know that total power is nothing but power in output plus power in even part. Here 1 by x naught of n whole square, n is minus infinite to infinite, n is minus infinite to infinite, xe of n whole square. So even power is nothing but minus 1 plus 2e power n equals to 0 to infinity 1 by 2 power n, which is 5 by 3. So p naught is nothing but 5 minus 5 by 3, which is 10 by 3. Hence option B is correct. Question is, a certain DAC has the lowest and highest of resistances 1k and 8k respectively. If the bit length of the converter is increased by 2, what would be the additional resistor and their values? Now here 2 power n minus 1 into R is 8 kilohertz and 2 power 0 R is 2 kilohertz. Means 2 power n minus 1 is equals to 4, that is 2 square. N minus 1 is 2, n is equal to 3. If the bit length is increased by 2, then n dash is nothing but n plus 2, that is 5. The number of additional resistors will be 2. Then the values would be 16k and 32k, hence option B is correct. Question is, match the list 1 with list 2. List 1, the type of feedback is given, whereas in list 2, effect on R input and R output is given. In case of voltage series, what happens is, we are taking the voltage from the output node, means that is a parallel connection which will decrease the output resistance, means R out decreases whereas series connection increases the input. Comes to B, R out decreases, shunt connection is also, both are decreases. Comes to C, current series, R out as well as R in both increases. Comes to D, current shunt means output increases but input decreases. Hence comes to voltage series means output decreases, input increases. So A is 1. Voltage shunt means both decreases, hence it is 3. Current series means both increases, hence option 2. Comes to D, current shunt means the remaining option 4. So A, B, C, D. 1, 3, 2, 4. In the circuit shown below, JFET has GM is 2 millisiemens and OD 40k, and the BZT has R pi and the beta. Here we know that for this is the first stage. This is AV1, this is AV2. Total AV is nothing but a first gain multiplied with the second gain. Here AV1 is nothing but minus GM RD parallel with RD parallel with HIE. Here HIE is nothing but R pi. Okay. Now AV2 is minus GM RC, whereas GM is for BJT beta by R pi, beta by R pi. If we take the product of these two things, we will get AV voltage gain as 190.5, which is option B is correct. In the circuit shown, JFET has GM and RD, and the BJT has R pi and the beta given as per the data given in the question. Now we have to calculate the gain. See, this is the first stage whose gain is AV, second stage is AV2, first stage gain is AV1. Total voltage gain is AV1, AV2. Here, first stage gain is AV1 is nothing but GM RC, whereas GM of BJT is nothing but HFE by HIE, which is nothing but beta by R pi, whereas second stage gain is AV2 is minus GM, which is GM of FET, which is given in the question as 2 millisiemens RD parallel RD. So total AV is nothing but the product of these two. If we calculate, we will get it as 445, which is, we will get the total gain as 445. Check the following diagram. Thevenin's voltage across VXY is. Suppose if we indicate this as VA, VXY is nothing but VThevenin's, which is nothing but VA plus 5. Here VA we can get it as VA minus 10 plus 10 divided by 5 plus VA minus 10 by 5 equals to 0. This is cancel. 2 VA minus 10 is 5. VA, here 2 VA minus 10 equals to 0. VA equals to 5 volts. Hence VThevenin's is 10 volts. Hence option C is correct. Consider the following diagram. The load resistance to be connected across X and Y such that it dissipates maximum power. So in order to find out what resistance we need to be connected across XY in order to transfer the maximum power to that load, see, we have to convert the entire circuit into Thevenin's equivalent. So if we find out Thevenin's resistance, then we're going to know what resistance we need to be connected across the XY in order to transfer the maximum power. That is, RXY must be R Thevenin's for the above circuit. So we have to calculate the RThevenin's. In order to calculate the RThevenin's, we need to open the independent current source. We need to short the independent voltage source. Then we will get RThevenin's we will get as 7.5 ohms, which is option C is correct.